Hello everyone. In this video we are going to see the different rules of Boolean algebra. So the Boolean word means the bool denotes a single bit, okay, and the rules for designed for different the different logic operations is called Boolean rules, Boolean algebra rules, okay. Now why it is called Boolean algebra? Because we are having some arithmetic and some multiplication rules, okay. So starting with the first basic fundamental rule, Boolean rules. The first rule is a plus 0. So a plus 0 is equal to a. That means this is the logical OR operation, okay, logical OR operation. So a is equal to, suppose if we place a is equal to 0 and other input is 0, then output will be the first input, that is 0. If you will put a is equal to 1, then here 1 plus 0, the output of OR gate will be 1. So that's why a plus 0 is equal to a. Okay. Second rule is a dot 1 equal to a. So here the dot represents the AND operation. Okay. So if first input is unknown and second input is 1, then whatever the first input is given to the AND gate, the same will be given, same will be come to its output, that is a. If you will place here 0, output will be 0. If you will place here 1, output will be 1. So that's why a dot 1 equal to a. The third rule is a plus 1 equal to 1. So this is, the first rules are identity law. That means the input comes at the output. Okay. Then annulment law means what? The output comes in terms of 1 or 0. Okay. We can firmly say that it is 1 or 0. That's why it is called annulment law. So here a plus 1 is always 1. So as we know that the 1 plus anything, that means OR operation, if first input is 1, logic 1, and second input is anything that we don't know, then we can firmly say that the output of OR gate will be 1. So that's why a plus 1 is equal to 1. Then second annulment law is a dot 0 is equal to 0. So here the product, this is the product of a and 0. So here if any one input is logic 0, the output of AND gate will become 0. Okay. Now the next one is idempotent law. So idempotent law means if both the inputs are same, a plus a, then output will be a. And the same case, in case of AND gate, a dot a, that means both the inputs are same, the output will also be same. Okay. Now the next rule is complement law. So complement law means if the first input is a and the second input is complement of first input, then what will be the output? That is called complement rules, complement law. So here a plus a bar is equal to 1. That means if I will place here 0, then this second input will become 1. So 0 plus 1, output is 1. Or suppose if I will place here 1, the second input will become complement of first, that is 0. So 1 plus 0 is equal to 1. Similarly, a dot a bar. So here AND operation is there. So if the first input is 0, second input will become 1. So 0 dot 1 is equal to 0, or 1 dot 0 is also 0. Okay, so this is our complement law. Ninth rule is double inversion law. So double inversion law means a double bar is equal to a, right? So double bar means what? It is like we are using two NOT gates. Okay, the NOT gate inverts the input at its output. So if the first NOT gate is having logic 0 as an input, the output of first NOT gate will become 1, and the same 1 will be given to the second NOT gate, and it will be again complemented. So that's why you will get their original input as an output after making its double inversion. Okay. Now the 10th rule and 11th rule are commutative law. So commutative law means a dot b can be written as b dot a. So here the sequence of input doesn't matter. Sequence of input doesn't matter. Okay, A dot B can be written as B dot A, or you can in case of logical OR operation you can write simply A plus B is equal to B plus A. Okay, now one more thing I want to tell you. You can write here in case of XOR or XNOR also. So the same rule, the same commutative law can be applied for XOR and XNOR also. A XOR B can be written as B XOR A, or A XNOR B can be written as B XNOR A. Okay, so XOR and XNOR can also work for commutative law. Now let us see the next rules. The next rule is A plus A bar B is equal to A plus B. Okay, so you may think that how this output is coming. So A plus A bar B is equal to A plus B. For example, suppose if you write here X plus X bar C, then the output will be X plus C, because if the first input is single and the complement of first is multiplied with the another variable, so the output will be first input, first variable plus that multiplied variable. Okay, so let us see how this equation is approved. Okay, so consider our input is what, A plus A bar B. Then what will we do? We can simply write here A into 1 plus A bar B. So multiplying with 1 is meaning is same, right? So A, I can write here 1 plus anything, 1 plus B A bar B. So here 1 plus anything is also 1. So it doesn't make any difference, right? So what will I do? I will simply multiply A into this bracket. So A into 1 is A plus A into B is AB plus A bar B, right? Now the second step is, so here B and this B are common, right, in these two terms. So I will simply take out the common term B, and what remains inside the bracket, A and A bar. So A plus A bar, A plus B. So A plus A bar is what? A plus A bar is 1. So no need to write here 1. So the answer is A plus B. Okay, so we have got here A plus B. Now the 13th equation is the dual form of the 12th equation. Because what is meant by dual? Dual means convert plus to dot and convert dot to plus is called dual. Okay, so if you convert the first equation into its dual form, then the meaning will not change. Okay, the meaning will not change. Now here the plus is converted into dot and this dot is converted into plus, right? Now this plus is converted into here dot. So both equations are one and same. Okay, understood? Now let us see the next Boolean expressions. Okay, so till that time just solve this quiz. Okay. Now let us see the next rules of Boolean algebra. So here the next rule is De Morgan's theorem. So De Morgan's theorem says that if you have whole bar of any AND operation or OR operation, and if you want to convert it into OR AND operation, then the bar can be separated. Okay, so here the input is a plus b whole bar, and if you want to divide this bar on and give it to the separate inputs, then the plus will be converted to dot. Or here, if the a dot b whole bar is written, and if you want to change this sign, that is dot to plus, then this bar will be separately given to separate inputs a and b. Okay, so this is the De Morgan's theorem. Okay, so next theorem is distribution law. So here the distributive law says that a into, suppose equation is a into bracket b plus c, then we can multiply this a into b into bracket, so that ab plus ac. So this is our distributive law, and you can convert this same equation into its dual form, as convert all the dots to plus and convert all the plus to dots. So that is the dual form of the equation. So here the dot is given here, or you can it is not necessary to give that you should give the dot here, because if you don't give the dot, then it is assumed as it is the product. Product means what? AND operation, right? So here this dot is converted to plus and the plus is converted to dot, that is product. Okay, here now the meaning of first equation, or if you multiply a into b and a into c, then you will get here ab plus ac. Okay, similarly you can simply convert this dot to plus. Here plus is converted to dot and this dot is converted to plus. So no need to calculate again this how this comes. Okay, because if you want to check whether this a plus b into a plus c is really equal to a plus bc, then we can see. So I will take here a plus b into a plus c into a plus c, and if you will solve this equation, then you will get a into a is what? A dot a plus b into a is a dot c plus a dot b and b dot c. Now here a dot a means what? Simply a. Now a is common in these three terms. Okay, so you can take a as common. A here, what remains in the first term? 1 plus c plus here b plus bc. Next, now we know that 1 plus anything is equal to 1. Okay, so I can simply write here a dot 1 plus bc is equal to a plus bc. So this way you can conclude that a plus bc is equal to a plus b into a plus c. Okay, now the next law is absorption law. In absorption law, a plus ab is equal to a. So here the which operation is performed here? Plus operation. So that's why this is OR absorption law, and here the two terms are separated out by using dot operator. That means this is AND absorption law. Okay, the first here you can take simply a is common. So what remains inside the bracket? 1 plus b. So 1 plus anything is what? 1. So finally the common factor remains as a. Now you can simply convert this equation into its dual form by converting plus to dot and dot to plus. Okay, so here I have converted plus to dot and dot to plus. Okay, so again the answer is will remain same. If you multiply this a into a plus a into b, a into a plus a into b, so output is remain again, it will come to a plus ab, and it will the next step is a. Okay, now the next law of Boolean algebra is associative law. So associative law tells that you can group of different inputs irrespective of the sequence. Okay, so here a plus bracket b plus c is written. You can write the same equation as bracket a plus b bracket complete plus c. So that means I want to say that you can group the different inputs. Okay, you can group the different inputs. Okay, so that the meaning of the equation will remain same. Okay, so a, or you can finally write this equation as a plus b plus c. So meaning of all these equations are same. Now in the same way, this is OR associative law. This is for OR gate associative law. Similarly, you can use for AND associative law. Okay, so here instead of plus, I am just converted here dot, plus 2 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 dot. Okay, so this way you can write associative law for AND gate, AND logic. Okay, so A dot BC can be written as AB dot C. Okay, or you can simply write here A dot B dot C. So meaning of all these terms, all these equations will remain same. Okay, but what I want to say that this law is not applicable for NAND gate and NOR gate, because if you group the different signals, then the output of NOR gate and NAND gate will be different. So let us see with the help of one example. Now consider A equal to 1, B equal to 1 and C equals to 0. Okay, and I want to perform A. Suppose the equation is written as A NAND B NAND C. Okay, so first suppose we will take B NAND C, and then we perform with A. So here A is what? 1. Okay, then NAND. Now B NAND C, 1 NAND with 0 is what? If any one input is 0, then output of NAND gate will become 1. Okay, that we have seen in the previous video. Okay, logic gate video. So 1 NAND with 0, the output will become 1. Now 1 NAND with 1 is what? 1 NAND with 1 is 0, right? So output will be 0. Now take the another case. Suppose I will make a group of A NAND B first, and then I will perform the next NAND operation with C. Okay, now let us see A NAND with B first, and whatever output of this group comes, that will be NANDed with C. Okay, so A is 1, B is 1, so 1 NAND with 1 is what? 1 NAND with 1 is 0, right? Now 0 NAND with C means C is 0. Okay, so 0 NAND with 0, output is what? 1. Okay, so you can see the difference. This is 0 and this is 1. So here this associative law does not work for NAND gate and NOR gate. Okay, in the same way the NOR gate works. Okay, so associative law does not work for NAND gate and NOR gate. Okay, now the next thing is consensus theorem. So consensus theorem says that if there are three terms AB plus A bar C plus BC is equal to AB plus A bar C, that means suppose here A and A bar is taken, and this the first variable is a and its complement is in the second term, and the first term is multiplied with b and second term is multiplied with c, then and these two terms are available in the product of b and c as the product of b and c. Then this b and c will be vanished and the first two terms will remain as the output. Okay, now let us see how this first two terms remains as an output and the third term will be vanishes. Okay, so what we will do, we will simplify this equation a bar c b c. Now can I write here 1? Okay, the meaning will remain same. Okay, so doesn't matter. Now what will I do? I will simply write 1 means a plus a bar. A plus a bar. So still the meaning is same. There is no any change, right? So a plus a bar. I will just multiply this BC into the bracket. So a b c and a bar bc. Okay, now in the first term and the third term the AB is common part, right? So I can take here AB is common, and in the second term and in the fourth term the A bar C is common, right? So you can take A bar C as common. So first and third term we can take AB as common. So AB, what remains here? 1 plus what remains here? C plus here A bar C is taken common. What remains in the second term? 1. What remains in the fourth term? B. Right? Now 1 plus anything is 1, that we know. So AB into 1 is AB plus 1 plus anything is 1. So A bar C into 1 is A bar C. So this is our output. Okay. Now I hope you have understood all these Boolean algebra rules, and whatever what quiz I have given you in the middle of this Boolean algebra rules, just solve that quiz and write your answers in the comment box. Okay. So if you liked this video, then click on like and share with the maximum. Thank you.